question 2B, August 2024, question 2B. So from your past papers, please have that. August 2024, question 2B. That is the question we are starting with. Are you there? Now, are we looking at part B of that question? Now, before we look at part B, look at part A. Part A says, describe 3 types of money market instruments and their related transactions available in the financial system. That is from topic 2 that we covered. And we talked about the money market. Money market, remember we said is the market for short-term funds. Market for short-term funds. So there you find treasury bills, you find commercial papers, promissory notes, and the rest. They are there in the handout that I shared. So let's go to part B. I want, if possible, we do away with this topic today. So I want us to move a bit faster, yeah? So part B, Samuel Mongeka intends to invest shillings 200,000 at the beginning of each year in treasury bonds, which earns a return of 9% per annum. So Samuel Mongeka intends to invest shillings 200,000 at the beginning. At the beginning is very important. At the beginning of each year in treasury bonds, which earns a return of 9% per annum. Required, determine the accumulated value of investment after 10 years. So remember, this person, we're being told that this person will be investing 200,000 at the beginning of each year for a period of 10 years at an interest rate of 9%. So the 200,000 is an annuity. 200,000 shillings is an annuity in this case. So you say annuity. So this is part 1. So annuity is 200,000 because this is happening each year. So it becomes an annuity. Then the interest rate is 9%. 9% per annum. 9% per annum. The required, that is investment after 10 years. The number of periods is 10 years. So he's going to invest for a period of 10 years. This is an annuity due because it is occurring at the beginning. So present value of annuity due, we said is equals to the annuity times. So here we can choose to use we can use the tables or we can use the formula, whichever you want. So let's use the formula for this one. 1 minus 1 plus R. Now we want the future value. We're looking at the future value. So yeah, we are computing the future value, not the present value. So 1 plus R power n minus 1 over R times 1 plus R times 1 plus R. That is the formula that we said for future values. So yeah, so we are going to change here. It's not present value, it's the future value of an annuity, because we are looking at the value of the investment at the end of 10 years or after a period of 10 years. So, and I want to believe we are together. Are we together? So let's proceed. So here we say, the annuity is 200,000 times 1 plus 0.09 power what? Power 10 minus 1 over 0.09 times 1 plus 0.09. So from that, we can get the amount. Get me that figure kindly. You're taking too long, kindly. Yes, you're getting 33, 120, 33, 120, 58.68. So it's what? Sorry. So this is here. It's 3 million. Okay, fine. So that must be the correct answer. That must be the correct answer. So the keynote here, it's the beginning. Remember the question says at the beginning of each period. And that is why we are having this factor here, 1 plus R. So take note of that. Then next part B, not part B, but part 2. Determine the present value of shillings 1.2 million annuity payable for 20 years at an interest rate of 8% per annum. So here, they're saying, determine the present value of shillings 1.2 million annuity payable for 20 years at an interest rate of 8% per annum. So again, this is still an annuity. And this annuity, they're saying, it is 1.2 million that is payable annually for a period of 20 years. So here we will say the annuity is 1.2 million. 1.2 million payable for 20 years. The period is 20 years at an interest rate of 8% per annum. Interest rate is 8% per annum. And we're looking at the present, determine the present value of shillings 1.2 million annuity payable for 20 years at an interest rate of 8% per. So they have not said whether the amount is at the beginning or as at the end of the period. So when the question does not specify when the payment is being done, it is assumed to be an ordinary annuity. So this is an ordinary annuity where the payment is occurring at the end of each period. So present value of annuity, which is an ordinary, we said is equals to the annuity times 1 minus 1 plus R power negative N over R over R over R. So this is 1.2 million times into brackets 1 minus 1 plus 0.08 power negative 20 over 0.08. So get that. Get the present value. Get me the present value kindly. I'm waiting for the answer. Hilda? Eleven 781 720. Eleven 781 776. Point 89. Let's say 89. So that is okay. That is how we get the present value of an annuity. So you can see, these are the same things that we were looking at during our classwork. What you need to do is to get the concept. You need to understand what you are computing, what information has been provided. Have I been provided with an annuity? Have I been provided with a lump sum? And things like that. Let's have another question, a quick one. December 2023. December 2023. December 2023. Question 3C. December 2023, question 3C. for December 2023, question 3C. Are you there? Yeah, question 3C say, no. This is on loan amortization, yeah? This is on loan amortization. December 2023, question 3C and D. Let's do part D. Let's do D, not C, D. We are coming back to part C on loan amortization. So let's have it somewhere. Question 3C. It's on loan amortization. So let's look at part D. Says, 𝐎𝐍𝐋𝐿 has the following investment options to choose from. 𝐎𝐍𝐋𝐿 has the following investment options to choose from. Post office MIS scheme, monthly interest, 8% per annum. ICD bank deposit, quarterly interest, 8.25% per annum. HDFC Limited have yearly interest, 8.5% per annum. Required, using effective interest rate method, advise 𝐎𝐍𝐋𝐿 on the preferred investment option using the effective interest rate. So remember, we said effective interest rate. Effective interest rate, it is adjusting the nominal interest rate with the number of times compounding occurs in a year, so as to get an interest rate that is consistent with the number of compounding times. So effective interest rate, we said effective interest rate, we said is equals to 1 plus, this was R over M power M minus 1. That is what we said. That is how we compute the effective interest rate. That is how we compute the effective interest rate, unless I'm getting the formula wrong, but that must be correct. 1 plus R over M power M minus 1 minus 1. So we compute the effective interest rate for each option, and we start with the post office MIS. Post office MIS, where the nominal rate is what we call in RR, 8% per annum. M is 1. Here M is 1. Because if it's the interest rate is per annum, or it's monthly interest rate, monthly, they're saying post office MIS scheme monthly interest. So M is 12. M is 12. M represents the number of times interest is compounded in a year. The number of times interest is compounded in a year is what you're calling M. And in this case, they are compounding monthly. So M is 12. So then the effective interest rate is equals to 1 plus 0.08 over 12 power M 12 minus 1. So get the interest rate here. Get the effective interest rate. Then we will go to ICD bank deposit. Let's first write, then we will compute. Let's first have this, then we will compute. ICD bank deposit, they're saying quarterly interest. So our nominal rate is 8.25% per annum. M, the number of times compounding occurs in a year, it is quarterly, so 4. then effective interest rate is equals to 1 plus 0.8 0.0825, you divide by 4, then power 4 minus 1 is equals to, and the last one is HDFC Limited. HDFC Limited. Here the nominal rate is 8.5% per annum and half yearly. So here compounding occurs semi-annually, so it must be 2 times in a year. Effective interest rate is equals to 1 plus 0.085 over 2 power 2 minus 1. So now let's compute now. Let's compute. Get me the answer for the first one. Kindly save time, save on time. I've said I want us to do away with this topic today. And we have a lot to cover. %8.29%. Okay, whatever answer you are getting, multiply by 100 to get it in percentage. So now the answers are too many here. So for this is 8 point. Oh, that's okay. That's okay. 8.29, 8.3 is okay. Otito, yours is for which one? Because yours is a bit different. ICD. Okay. 8.51. Let's have the answers in 2 decimal places. 8.51. 8.51. Then the other side, HDFC, 8.68. 8.68. 8.68. So I believe that is okay with everyone. A vote that is for 8.5, or that is for this one. Okay, fine. Okay, thank you, Abod. That is it for that question. Unless someone has been left behind, we go to another question. Any question before we proceed? Oh yeah, we are supposed to advise. We are supposed to advise because the question says, using effective interest rate method, advise 𝐎𝐍𝐋𝐿 on the preferred investment option. The preferred investment option is the one that provides the highest effective interest rate. So which should be this one, HDFC Limited. So say the preferred investment option, advising the preferred investment option. The preferred investment option is HDFC Limited. Is HDFC Limited, since HDFC Limited, since it has the highest, effective interest rate. since it has the highest effective interest rate. It has the highest effective interest rate. Full stop. Then August 2023 question 5B. August 2023 question 5B. And I said, make sure you get the concept. Don't just compute, don't just write. Ensure you understand the question. And one thing, these financial management questions, if you want to get the concept and if you want to survive in financial management, number one, make sure you understand the question. Read the question and understand. Make sure that you can explain the story in that question, so that when you are doing the question, you're just converting whatever you've understood into writing. So like in this question, we're saying August 2023. Question 5B. August 2023 question 5B. That question reads, it's 5B. Joel Ouma needs shillings 5 million in 5 years' time to purchase a house. So this man wants to have 5 million shillings 5 years to come to purchase a house. Then he is determined to deposit a given amount of money each quarter in a sinking fund that earns interest at the rate of 12% compounded quarterly for 5 years. For 5 years. Required, compute the amount of money that Joel Ouma should deposit in each quarter in a sinking fund so as to enable him realize shillings 9 million in 5 years' time. And you can see that question is 5 marks. Very short, but 5 marks. Now, so let's start. Okay, this is now where understanding the question is coming in. You must understand what the question says, what it requires, so that you can know what to do. Now, in this case, you've been given the future value is 9 million. Say future value here. This is the money this person wants after 5 years. So then N is 5 years. Because they're saying Joel Ouma needs shillings 9 million in 5 years' time to purchase a house. He's determined to deposit a given amount of money each quarter. So he is depositing each quarter. So the number of times he's depositing money in a year is 4. Because a year has 4 quarters. So he's depositing 4 times in a year. In a sinking fund that earns interest at the rate of 12%, the interest rate is 12%, but compounded quarterly, at an interest rate that's, so they're saying he is determined to deposit a given amount of money for each quarter in a sinking fund that earns interest at a rate of 12% compounded quarterly for 5 years. For 5 years. So now the question is, compute the amount of money that Joel Ouma should deposit in each quarter in a sinking fund so as to enable him realize 9 million in 5 years' time. In 5 years' time. The amount of money that he should be depositing in each quarter in order to make it at 9 million after a period of 5 years. So here we have 2 methods. We can start by computing the effective interest rate. So, but before that, this is the future value. And we are looking for an annuity. We've just said that future value of annuity is equals to the annuity times 1 plus r power n minus 1 over r. That is what we've said. So the annuity, this is what we are looking for, because the annuity is the amount of money that he will be depositing each quarter. Then the future value of the annuity is the 9 million. So here you can say 9 million. This is the 9 million will come here. This is what we are looking for. How much should he be depositing to make it 9 million after that period of time? We will start with the effective interest rate method. Effective interest rate method, whereby we are supposed to adjust the interest rates to reflect quarterly. This interest rate here, this 12%, we said we are calling it the nominal interest rate. We said the nominal interest rate is given on annual basis. It is per annum. It is for 1 year, one financial year, or not just annual. It's an annual rate. So, but here, the compounding is done quarterly. That means you're supposed to adjust this interest rate of 12% per annum to reflect quarterly compounding. So here you can just say per annum. So we will start with this. Effective interest rate you're saying is 1 plus R over M power M minus 1. And I said, always in financial management, whenever you're doing a question, write the formulas. Write the formula. Even if you know it, just write the formula. It will even direct you on what to do. Like this one now, it will direct you. You will know this is 9 million. This is what I don't have. The rest I have. So here you'll say effective interest rate is 1 plus 0.12 over 4 power 4 minus 1. So get the effective interest rate. Get the effective interest rate. 12.55. 12.55%. Now this is what we are going to apply as our R. So we'll say future value. Oh, no, we are not repeating that again. We will say present value. Is it present value? No, future value is 9 million is equals to annuity. Annuity is what we don't know, times 1 plus 0.1255 power 5 minus 1 over 0.1255. So first get this factor. Get this factor in 4 decimal places. This factor should be in 4 decimal places. So annuity will be 9 million. You divide by the factor that you're getting here. Uh-huh, 6.4226. So please get me the amount here. Divide, you get me this amount. $140. This figure is too big, my friend. This is 1 million, eh? Someone else, kindly. Okay, fine. Let's see. Something must be wrong somewhere. This one is for 5 years. Just a minute. We will see. We will compare. We will see where we are going wrong, if at all we are going wrong. We said we have two methods of this. We said we have two methods of doing the multi-period. Remember, we called it multi-period compounding. Multi-period compounding. So just leave this the way it is. We will come back to this. I will check where the issue could be. Now we have this. We said, number one, you can adjust the number of periods. You adjust the number of periods, and again, you adjust the discount rates, and then you do the compounding. So method number two, this is number two. Just say or say number of periods will be 5 times M, 20 years. We will get 20 years there. Then discount rate. Discount rate, we said, sorry. This one should be, so I just wanted to say N times M, which is 5 times 4. You get 20 years. You get 20 years. Then discount rates will be R over 2. Not 2, but M. R over M. So 12% divided by 4. We will get 3%. We will get 3%. So we are saying, instead of using the effective interest rate method, we have another option. We have another option of adjusting the number of periods, because you're saying, if this person is going to save for a period of 5 years, and each year he is saving 4 times. So the number of periods will increase. So it's like saying, we have a period here. This is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. So these are 5 periods. 1, 2, 3, 4, 5. 5 years. But you're saying in each year is making 4 payments. So there are other periods here. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So these are not the period, because compounding is occurring quarterly. We are supposed to count this. 1, 2, 3, 4, 5, 6, 7. There will be 20. Then the interest rate that we have is for 1 year, 12%. But we are only compounding for quarterly for 3 months. So you divide by 4, you get 3, 3, 3, 3, which must add up to 12. That's why we're saying R over M, we're getting 3%. So with that now, we can apply this formula. We say annuity, which is 9 million. Annuity, which is 9 million. is equals to annuity times 1 plus 0.03 power 20 minus 1 over 0.03. So then now you say annuity is equals to 9 million over the factor that you'll get there. Let's have in 4 decimal places, Anna, in 4 decimal places. So you get in 33. Three 34, 941. So this is 26. It said 26, 26.87, 26.8704, 8704, 26.8704. Then here the annuity, you're saying shillings, 334, 941. 334, 941.05. So that should be the correct answer. That should be the correct answer. So that means here, we are supposed to adjust the periods again here. This one, this effective interest rate, we adjust. We adjusted to, like we've adjusted there. So it is the same thing. So here the number of periods will change. So here we are supposed to say divide by, just a minute. You divide this by 4. So this will become 20. Then you divide by 0.1255, you divide by 4. So that is where the issue was. After getting the effective interest rates, you will still again adjust the number of periods. So get that. Just check now. Check now. Okay, it will not be the same, but almost the same. Rounded off. Check whether you're getting the same. Enad, are you getting the same answer? Hi, 330. 330 is a bit low. If you divide 12.55 over 4, then you use 20 here. The same case here. This is becoming almost the same, 3 point something, 27.39. Or 332.82.81. 338.82.81. So I would advise we go with this. This will not complicate issues. This will give us the exact figure, this method. Because here we've adjusted the number of periods, we have adjusted the discount rate, we are getting full numbers, or rather whole numbers. Then we apply the formula, we get this. So this is okay. Let's go with this. Let's go with this. This is more accurate. That is more accurate. That's more accurate. Now, do we need to do another one? Let me see. April 2020, April 2023, question 5D. Let me see whether it's April 2023. If it's similar to what we've done, we're just going to proceed. So they're saying John Osoro has deposited 7 million into a savings account at an annual interest rate of 5% compounded, with additional deposits of 10 per month made at the end of each month. So this is a bit different. I've advised we go with this. Martin, I've advised we go with this method of adjusting the number of periods and adjusting the discount rates. This one will not mislead you. So let's have April 2023 question 5D. April 2023 question 5D. Question 5D. April 2023 question 5D. Now, John Osoro, that question for John Osoro. That question for John Osoro is what you're looking at. The question says, John Osoro has deposited shilling 700,000 into a savings account at an annual interest rate of 5%, compounded monthly. So John Osoro has deposited 700,000 into a savings account at an annual interest rate of 5%, compounded monthly, with additional deposits of shillings 10,000 per month made at the end of each month. Required, determine the value of the investment after 10 years. Determine the value of the investment after 10 years. So here we have a lump sum. We have a lump sum of 700,000, and we have annuities of 10,000 per month. And this will be done for a period of 10 years. So you need to get the present value of each separately. So here we have a lump sum. We have a lump sum of 7 million. We are saying shillings 700,000, sorry. 700,000. So initially he deposits 700,000 shillings into a savings account at an interest rate of 5% per 5% compounded. This is per annum at an annual interest rate, 5% per annum, but compounded monthly. M is 12. M is 12. The number of times compounding is occurring in a year is 12. Then compounded monthly with additional deposits of shillings 10,000 per month. Annuity. There is an annuity here. Shillings 10,000 per month. 10,000 per month. So what I'm saying, how we are going to get the present value of this lump sum is different from how we are going to get the present value of this annuity figure. Because here the question says, determine the value of the investment after 10 years. So here is saying value of investment. Value of investment is equals to present value of the lump sum. No, after 10 years. Determine the value of the investment after 10 years. So value of the investment is equals to future value of the lump sum, future value of the lump sum, plus future value of the annuity, plus future value of the annuity, future value of the annuity. Now, we need to adjust this here. Let's start by adjusting the number of periods. Number of periods, we have said, number of periods is equals to n. Where is n here? We don't have n. N is 10 years. N is 10 years. Number of periods is n times m. So n, 10 times what? 12. We get 120. So the number of periods is 120. Then the discount rate or the interest rate, we can just also call it the interest rate. The interest rate is R over M. 5% divided by 12. 5% divided by 12 because compounding is occurring. Compounding is being done monthly. So get the interest rate, that is consistent with compounding period. 5/12 is what? Five over 12. No, but this one, yeah, let's have it the way it is. 5, if you divide by 12, I'm getting 0.42. Let's say 0.42%. 0.242. Don't forget this is percent, because you are going to divide further by 100. We're going to divide further by 100. So we start with the future value of the lump sum. Future value of lump sum is equals to the lump sum is equals to the lump sum, or let's say future value of a lump sum is equals to present value 1 plus R power n. So this one will be 700,000 is equals to, or rather times 1 plus our R is now the adjusted one, 0.42 over 100 power the periods 120 power 120. That will give us the present value of the lump sum. That will give us the present value of the lump sum. Then future value of the lump annuity. Future value of annuity. Future value of annuity is equals to the annuity times 1 plus R power n minus 1 over R. Again, for R and n, we are going to use the adjusted values. We are going to use the adjusted values. So our annuity is 10,000. 10,000 is what we are saving monthly. So times 1 plus 0.2, 0.42 over 100 power 120 minus 1 over 0.42 over 100. So here we will get the future value of the annuity. So remember, the reason we are just dividing by 100 because we want to convert this percentage to numbers. We are converting the percentage to numbers. So basically, the 100 has no other reason to be there, because you can just say 0.0042 and you'll be good to go. So the first one I'm getting 1157,508. I don't know what you're getting. 1157,508. 1157,508. Confirm whether you're getting the same. 1157,508. Yeah, that's okay. Let's have the present value of the annuity now. So this one is 1 plus 0.0042. Close the brackets, power 120 minus 1 divide by 0.0042 times 10,000 times 10,000. I'm getting 1556 150. 1556, 150.42. I believe you're getting the same. 1556, 150.42 for the annuity, for the future value of the annuity. Then now you add value of investment, is equals to 1157,508 plus 1556, 150. Ignore the points. Ignore the points. So this is 2,713,658, 2.7, 271, 39.59. Bernard, why is mine different from yours? Who is right, who is wrong? 1157, 508 plus 2713, 658. Okay, fine. Mine seems to be okay. So that is how you do time value of money questions. Like I've said, here there is no format. It is just getting the concept. For example, this question that we've just done, this April 2023 question, 5D. Do you think you can do all this without having the concept? Without knowing that one is a lump sum and there will be an annuity, and also knowing that how you get the future value of the annuity is different from what you get used. You get the future value of a lump sum. Plus again, adjusting the number of periods with the number of times compounding occurs in a year and adjusting the discount rate to reflect the number of times compounding occurs in a year. Here, it is just getting the concept, not a matter of cramming or what. So just keep on. We've very many questions on this in the past papers. Even in August 2025, there was a question that's sitting, I don't know. So make sure you look at those questions. And in case you have a question, you will ask. Let's proceed. Let us look at something else because I want us to finish this today. Under that, right, loan amortization schedule. Loan amortization schedule. Loan amortization schedule. Loan amortization schedule. Now, a loan amortization schedule, this is a schedule that is used to determine the amount of installment that one should pay when they have borrowed money at an interest rate. The amount of installments one should pay. Now, for example, let's say when you acquire a loan of shillings 1 million at an interest rate of 12% per annum, and the loan period, you're supposed to repay this loan over a period of 4 years. So the question is, You have acquired a loan of shillings 1 million. You're being charged interest at 12% per annum. And the repayment period of the loan is 4 years. So the question is the installment. How much should this person pay per month? How much should this person pay per month to exhaust the loan amount in a period of 4 years? So in short, you are being asked to compute the installment, the amount payable each either year or each period to exhaust the loan amount plus interest over the period of the loan. And remember, when you borrow a loan, it will be the loan amount, like 1 million plus interest. The amount of money that you pay back, you're not going to pay the 1 million, no. You're going to repay the principal amount of the loan plus an interest that will be charged. So that means you're going to pay more than 1 million. And again, each installment that you make when you're repaying a loan, it has an element of the principal amount and interest. Let's say, for example, after doing all these calculations, we will realize that this person should be paying 35,000 shillings per month. Each installment that you're making for loan repayment can be split into two. It has an element of the principal and the interest expense. So you don't say that first I'm going to pay the principal amount, then after paying the principal amount, I will now start paying the interest amount. No. Every time you're making a loan repayment, you are paying an element of the principal and an element of the interest charged. And then you continue until you exhaust the principal amount plus the interest charged on the loan within the period of the loan. So just say one statement and say, write one statement and say, a loan amortization schedule, a loan amortization schedule usually shows the interest charged. A loan amortization schedule usually shows the interest charged for each period, comma, installments paid, and the balance outstanding, at the end of each period, and the balance outstanding at the end of each period, full stop. And say the annuities stroke installments can be determined as follows. The annuities stroke installments can be determined as follows. So what we are saying is this. An installment, remember, a loan repayment is done using equal installments. These installments must remain the same throughout the loan period. So what you're saying is that installment is equivalent to an annuity. So here we say, to determine the installment, you say present value of annuity is equals to the annuity times present value interest factor, annuity, R% power n. This is the same as this. This. So let me write here. We say this expression can be rewritten as this. When you're reading from the tables, you write this. When you're calculating, you write this. So now we're saying this present value is the loan amount. This is the loan amount. Because remember, the loan amount is in present value terms. You're getting the loan today, not tomorrow, today. Then you're going to pay in equal installments, annuities. So these are the installments. The annuity is the installment. So in short, we are saying the present value of the installments gives us the present value of the loan. Present value of the loan is equals to present value, or rather, the loan amount. The loan amount is equals to present value of installments. Present value of installments. So like if we were to do for this question, we would say, for this example, we would say 1 million. 1 million is equals to installments times present value interest factor annuity 12%. No, here the payment is being done monthly. When the payment is being done, when the installments are monthly installments, you must adjust this. So this will be 12% divided by 12. Then the number of periods here, 4, you say times 12. You get 48 months. So, but let's just have a past paper question for this. Unless you have a question. Any question before we do a past paper question? I want us to look at August 2024. Question 2B. Is it? August 2024. No, sorry. Not August 2024, but April 2024. April 2024, question 4C. April 2024, question 4C. April 2024, question 4C. You're saying April 2024. Question 4C. The question reads, a company negotiates a shillings 30 million loan for 8 years from a financial institution. So a company negotiates a shillings 30 million loan. So loan amount is 30 million. 30 million loan amount. Then, so 30 million shillings, 30 million loan for 8 years from a financial institution. The interest rate is 14% per annum. The interest rate is 14% per annum. Per annum. On the outstanding balance of the loan. So this is what we call the reducing balance method. The principal and interest will be repaid in 8 equal year-end installments. So the repayment period is 8 years. The principal and interest will be repaid in 8 equal year-end installments. Required, prepare a loan repayment schedule. 2, determine the amount of interest payable at the end of the 8th year. So we will start by getting the installments. Like I've said, the most important thing is to get the installments, the amount of the installments. So here, what we are lacking is the installment. This is what we are lacking. We're also very lucky that interest, or rather the repayment, is annually. They're making annual installments. That is what the question says. The principal and interest will be repaid in 8 equal year-end installments. So when we are making yearly installments, we don't need to adjust this. This and this will not be adjusted. So here we'll say present value of annuity. Present value of annuity is equals to the annuity times present value interest factor, annuity, R% power n. So the loan amount is 30 million. 30 million, 30 million is equals to, so this one you said is the installment. So let's have the installment here. Installment times present value interest factor, annuity, present value interest factor of an annuity, 14% for 8 years. For 8 years. So 30 million, okay. So if you divide both sides by what, you'll find that this is, divide this by present value interest factor annuity. No, let's not do that. 30 million is equals to installment times, get this factor from the tables. Get this factor, 14% at period 8. 14% at period 8. 14% at period 8. Go to the WhatsApp group, check the table that I shared the other day. Thank you, Tito. 4.63. 4.6389. And this one we are reading from the lower table. We are reading from the lower table because we are working with an annuity. So please, if you're not getting this figure, we are reading it from the lower table. So divide both sides by this factor. We'll say the installment is 30 million. You divide by 4.6389. 4.6389. So get that. Divide, get the installment. Oh, 64. 60. Priska, what is 73.82? 64, 67. 64, 67, 050. 64, 67, 050. 0.38. . 73.82 is what? Okay, let's now prepare the loan repayment schedule. Loan repayment schedule. Loan repayment schedule. So here we start with period. The period. We have 8 periods. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 periods. Thank you, Priska. 8 periods. So now here we will have balance brought down or balance brought forward, whichever. Balance brought forward. Then here you'll have interest. We are charging interest at 14%. We are charging interest at 14%. Then here we have installments. And here we have balance carried forward. Balance carried forward. So this is A, this is B, this is C. So this is A plus B minus C. A plus B minus C. A plus B minus C. Then this is the repayment fee, loan repayment schedule. Loan repayment schedule. Now, we are saying interest is being charged on reducing balance. Interest is charged on the amount due. So after you repay, the next time you're calculating interest, you calculate on a lesser balance. So we will have this. So we start with the 30 million. 30 million is the balance brought forward in period 1. 30 million is the amount brought forward in period 1. Charge interest. We charge interest on the 30 million. We charge interest. So 14%, 14% times 30 million, 1, 2, 3, 1, 2, 3. 4.2 million. 4.2 million. Then we have an installment. We make a payment of 64, 67, 050. Let's do away with the points. Let's do away with the points. Remember, the installments must remain the same. So you can drop the installments 64, 67, 050, 64, 67, 050, 64, 67, 050, 64, 67, 050, 64, 67, 050, and 64, 67, 050. After paying the last installment, we should have a 0 there. We should have a 0. Remember, we have said installments must remain the same. They are constant amounts. So let's continue. Now we want to get the balance carried forward here. So the balance carried forward here, we are saying, is the balance brought forward plus interest minus the installment. Minus the installment. So you say 30 million minus 4.2 million. Plus you add interest. Interest increases the amount due. Which is which here? Minus 6467. So you're saying 30 million plus 4.2 minus 6467, 050. 27, yes, 27, 732, 950. Then this one, you bring it forward here. 27, 732, 950. Bring it forward here. Then you charge interest on this figure here. Charge interest on the balance brought forward. Again, 14%. So this is 38, 82, 613. 38, 82, 613. Add 27, 732, 950, and you deduct the installment 64, 67, 050. Here I'm getting 27, 148, no, 25, 25, 148, 513. 25, 148, 513. That is what we're going to bring forward here. 25, 148, 513. Then again, you charge interest. It's 3520, 3520, 791.82. 791.82. So then plus 25, 148, 513, minus the installment, 64, 67, 050. So here I'm getting 22, 22, 202, 254.82. That is what we bring forward here. So here brought forward, it's 22, 202, 254.82. Charge interest at 14%. This interest is 3,108,315.67. 0.67. Then we get the installment, not the installment, but the balance there. So this is plus 22,202, 22,202, 254.82 minus 6467, 050. So here I'm getting 18, 843, 520, 0.49. So here 18, 843, 520.49. Then times 1.4. Then 2638, 092.87. So 18, 843, 520.49 minus the installments, 6467, 050. So here I'm getting 15